Cool. We like. Cool. Hello everyone. Before we get started, I should introduce myself. My name is Sam. I'm a PhD student with the department, and I've been here for a very long time. I was a fresher in 2015 at the department. I did my undergrad here, and now I'm doing a PhD here. So today's talk is going to be about Git, which is a very, very useful tool that really everyone, I think, should have an appreciation of coming out of their degree. Talking a little bit about what I'm going to talk about today. So I'm going to try to cover three main things. But really, I think the first two are the most important, and if you take nothing else away, those are the things that you should be learning. So I'm going to explain what Git is and why you should care about it. And I'm going to explain why other people care about it and why other people care that you should care about it. And I will go through some of the basics of what Git does and how it works as well. But you shouldn't feel any pressure to memorize any of that now. I mean, this talk's being recorded, you can always watch it back. And also there are lots of tutorials online for knowing the specifics. But I just want to talk about sort of the general concepts. It's going to be quite a light talk. I'm going to teach you enough so that you can work with it on your own. But I'm not going to teach you everything there is to know, because if I were to do that, this talk would be about 20 hours long. And I only have an hour. So, okay, let's start to talk about Git. So this might be a familiar experience to people. I'm pretty sure that 90% of people have done something like this before, maybe at school or something like that. Sometimes you want to save different versions of a project and tag them differently so that you know what each version contains and things like that. I think a lot of people have done this at school, and you might have done it with code, or you might have just done it with things like essays or stuff. This is not a bad thing. This is perfectly natural, because sometimes when we're writing something long and something complicated, we want to maintain several copies of it, and they're going to be near identical, right? Because we're working on this thing over a period of time. But these copies are a hassle to manage. You don't really know what each one contains just by looking at it, maybe. I mean, maybe you'll tag some of them like, essay with conclusion .doc or something like that. And collaborating on this is a nightmare. I mean, collaborating is made a bit easier by using things like Google Docs and stuff like that, but then you've got the issue of sort of discovering the past. If you want to go back to an old version to get something, it can be quite difficult sometimes. And with code, it's even harder. But, it is well motivated. We do care about the history of files. Sometimes we want to go back and grab something from an old version that we might have deleted, or things like this. And we want to be able to find points in the past easily. We also sometimes want to experiment with things and decide whether we want to include them in the final version of our project. Now, in this talk, I'm going to be mainly talking about source code and programming, but this can apply to long-form writing as well. We want to have a way to revert changes that we tried and didn't work out. And it's important, especially for team projects as well. So, Git is a type of version control software, right? So it's software that tracks changes to source code. So we've got this very complicated program that we're writing, and we want to have lots of little save points along the way, and we want to tag those save points with information to tell us what we were doing then and what we were thinking then. Sometimes it's called source control management. Now I've got some examples on here. But apart from SVN, the other two aren't really used. And it really is the case at this point that Git is extremely popular and is basically the de facto standard. And this has changed even, I've been doing this talk for 3 years, and this has changed even while I've, in the 3 years that I've written this talk. I've had to revise that number up and up every year I've done the talk so far. And it's just completely ubiquitous at this point. A lot of people watching this talk will probably go on to become a software engineer when they graduate. It's a very common career path. Or you might be writing code in some other capacity anyway. And this is just something you have to know. It's almost as important as knowing how to type in terms of becoming a software engineer. Version control is so ubiquitous it will be used any way you work at. It's used to manage extremely large projects, and this is just a selection. I mean, there are so many open source projects out there that use Git to track themselves. And it's used by pretty much every major company you can think of. There are a few big tech companies that use some sort of source control other than Git, like the ones we mentioned on the previous slide, but there really aren't many of them. It's mostly Git now. And at university, definitely, you'll encounter nothing else. So this is an extremely important tool to learn how to use, and I'm going to go through the basics of it and some of the themes and some of the techniques today. But really, I think... I'll get to what I was going to say this. So it's quite old at this point. I'm very scared about having to do this talk in the future and revising that number higher than the age of the people sitting in the audience, but that will happen in a couple of years. It is just the standard now. That's its official website. So just so that we've got that information. And it's open source too. It's open source, and interestingly, it uses Git to track itself. So that's the why should you care about Git portion of the talk. It's an extremely useful skill. It's in extremely high demand. You need to know about it, really. You won't be taught it particularly formally, except for maybe 1 or possibly 2 modules during the course of your degree. So it's really on you to learn how to use it in your own time. And I really, really strongly recommend using Git to manage your courseworks and any other programming you do as a hobby. Right? It's extremely important, I think. So, let's talk about some basics of how Git works. So, you've done some Linux 101 labs recently, so you should be at least starting to be a bit familiar with the command line. Git uses a particular way of doing commands called subcommands. So, when you're working in a terminal, you'll often type git and then a subcommand and then some arguments. And we'll go over what some of those subcommands are in this talk. Each command has lots of flags, and you can find out what those options are by using man, which I think you've also covered. You should be comfortable with. So the first one, the most important one, we've got this project, we're writing a piece of code, and we want to track some changes. So we need to tell Git that our project exists. So we need to create a repository, and we do this using the init subcommand. So git init is just, hey Git, I have a folder, please track the changes to it, or please help me track the changes to it. So whenever you see repository or repo, just think project, right? It's a piece of code, so it's a big, big directory full of stuff that you want to track the information on. So I've got this demo that we're going to be using to sort of explain some of these concepts, and I've just got it as screenshots in the slide. So I'm not going to actually do any typing. I'm not going to do any live demos because they will always go wrong. So git init. Let's see how we use git init. So let's say we're working for Fibonacci Industries, and the piece of code that we're writing is a program that will output the first 10 Fibonacci numbers. It's a very simple piece of code. The code is not important if you don't know Python. This just outputs the first 10 Fibonacci numbers. And if we run this piece of code, the first 10 Fibonacci numbers will pop out. Very easy piece of code, and we'll be modifying this throughout the course of this talk. So by typing git init, we initialize an empty sort of Git project in this Fibonacci folder. Now, if we look at all the stuff that's in this directory, and we need to use -a, we'll see that there's now this folder called .git. Now, this is what Git uses to store all of the information to do with the tracking of your code. Never touch it. You don't need to. You interact with it through commands. You can change stuff in there, but you run the risk of damaging stuff. Just leave the .git folder alone. But anyway, you know that Git is now tracking it, because there is a .git folder there, and you're going to use some commands to interact with it. Now, I should say as well, you can see here that there's this little bit of my command prompt that has some extra information. We'll go over what that means in a bit. Don't worry about it for now. So that's how you make a new repository. Now, it doesn't track stuff automatically. You have to tell it what bit of information to track and how often to track it and this sort of thing. And we'll talk about that now. So we've written this first pass of our Fibonacci program, and we want to save our progress. We've got it, it's working. You know, we've seen that it prints out the thing that we want it to. So now we want to sort of create a save point. We want to mark this as a moment in history where we've got a working copy of our program. How do we do that? Well, we do that with commits. Now, this is maybe a slightly bad name for what we're going to talk about. But a commit is just a snapshot of history. It's like a save point, if you like. And they all have names, but it's just a long series of letters and numbers which you can uniquely refer to them by. They also have a description which you put in when you create the commit or save point. It might help for some of you if you just swap the word commit out in your head for the word save point every time I say the word. It's a slightly more helpful idea. We're not going to talk about the way Git stores commits, just Git keeps track of them and it's all magic. Just think of it like that. So we need to talk about one more thing before we actually make a commit. We need to talk about something called a working directory. So this is the state of your project. Okay. So this is what your project structure looks like at any given moment. If it's identical to a save point, we call it clean. It's a clean working directory if it's identical to one of your commits. But if not, we can use the status subcommand to find what's changed. So let's run the status subcommand, and we should see that it's not identical to any of our save points because we haven't made any save points yet, right? So yeah, we type this thing called git status, ignore the thing that talks about branches, we'll come to those later. It says no commits yet. We've not created any save points, we haven't done it yet. And it says that there's a file here that's untracked. So this is our Fibonacci program. It's not tracked yet. Well, what does that mean? It means that Git isn't keeping track of the changes to it. So we need to create a new commit that adds this to the project and sort of shows us what's happened so far. And Git gives us a bit of a hint about how to do this. It says use git add to track. So let's see how we do this. So we've made changes since the last commit that we've done. To make a new commit, we stage our changes. This means kind of to tell Git that these are the changes I want you to track for this save point. Note, by the way, that we don't have to stage everything that we've done. It might be we really want to stage a couple of files or something like that. And we do that using add. And then we use commit to make a new commit with those changes incorporated. So we make a save point with the changes that we've told Git to save. And we can use some flags, and I'll show you how those work in a second. So we want to track the file Fibonacci.py, so we write git add Fibonacci.py. So that tells Git, well, this is what we want to save. We run git status, and now this is in green, which is of course the happy colour. And it tells us that we are going to commit the change to this file. We're going to commit the change to this. So we're going to start tracking this file now. And then we can write git commit, and we can add a message as well. So we can say first pass of Fibonacci program. And it's all happy, right? It's saved that progress for us, and that is now a save point in the history of our program. So in a bit, we'll be able to look back and we'll be able to see, oh, at one point in history, our program looked like this, and it was just a first pass of this program, and that was where we were. We're going to make some changes to this now, and we're going to add stuff to it. And let's actually do that. Let's make some changes to this program, let's enhance it a bit, and let's have another save point on top of this one, so we can get an idea about how this all works. Oh yeah, sorry, if we run git status now that we've actually done the commit, well, it's identical to a commit state, right? It's identical to a commit, so there's nothing to report, and it shows up as sort of empty and happy. So, let's change this program now. I mean, we just printed the series of numbers. Let's add a little string. I do realise red on dark is a little hard to read, apologies about that. Let's have this string at the beginning that says, the first 10 numbers in the Fibonacci series are. This isn't a big change, we're just, adding a bit of explanation to our program. Now if we run it, sorry, actually let's also add another file as well. Let's add another file. And this file is, if you see right at the bottom, it says readme.md. It's just a markdown file, it just explains what our project's about, and I just said I wrote this for a talk. So we've made two changes, right? We've added a new file, and we've modified an existing file. So let's make a new commit, or sort of save point, and let's record those changes. So if we run git status, we'll see there are two things that have changed. We've got the new file, and we've got the modified file. And now we can add them individually, so we can write git add, and then the two files that have changed or are new. Or we can save a bit of time, and just say git add --all, which will just add all the files that are changed or are new, whatever. And if we run git status, it's before we commit, after we've added, before we've committed, it will say, oh, if you commit now, these two things will be saved. And we can commit. If we use the -v flag instead of the -m flag, which we used before, it opens our editor, and we can do, well, we can write a longer description. Sometimes when you write, well, quite often actually, when you write commits, you're going to want to write a nice long description just to explain what you've done. The first line is treated as the sort of title of the commit, and the rest of it can just be bullet points or whatever. So the title is added user-facing explanation, and we've added a description, we've added a new file. If you save and quit your editor, the commit will go through, and Git status says that there's nothing to commit. Okay, now, I know this is a lot to take in. Shouldn't feel any pressure to memorize any of this, as I say. I just want to kind of let the ideas wash over you. I think that's the more important thing. If you come away from this talk understanding at least roughly what is happening, then that's a success. And you can look into this in your own time, 6 months down the line, and sort of recover any of the specifics that you need to. But it's good to have like a mental model of what is happening when we do this work. Okay, quick break. Anyone got any questions? Quick show of hands, are we all relatively happy with the content so far? Cool, awesome. Okay. Anyone completely lost? A couple of people arrived a bit late. Okay, no worries. I'll try to explain the concepts going forward in a way that doesn't rely on what we've just talked about. But we'll see how I can do that. Okay, so we've got these save points, right? But this doesn't matter unless we have some way of looking at them. So let's look at log. So we can see the history of our project, our repo, using the log subcommand. And actually, by default, if you just type git log, it looks a bit ugly. So I like to use a lot of options. And my personal favourite is this set of options, actually. One line, decorate, graph, and all. Let's see how that looks. Okay, I mean, it doesn't look great. But we get to see the history of our project, right? The two commits we made, we can see them on top of each other. The newer ones are at the top, the older ones are at the bottom. Some projects will have thousands of these, so it's nice to just be able to focus on the top ones if there are too many. Now, you'll notice something else at the top there. It says head and main. Don't worry about that too much, although we're going to talk about that in a minute. But you can see that the commit messages are the ones that we put in, right? And yeah, so it's recorded the history of our project. Now, okay, well, that's nice. We can see the history of our project, but can we restore our project to any of those states? Well, yes, we can. I'm going to show you how to do that in a second. What I will say is, remember I said that the commits all have names, which are just a series of letters and numbers. Those are those yellow ones over there, right? So that's the name of the commit. And if you keep that in your mind, we can then use that to travel to these commits. So checkout is kind of how we travel around the history of our project. Okay, so we can travel around. Now we can visit a commit by using its hash, so that series of letters and numbers, and also we can refer to where we currently are by using it's sort of like a variable in Git. We can use the variable head. Interestingly, you can see that it says head up there, and it points to where we currently are in our project. And we can actually go back from a commit using a tilde, which means head tilde 1 will take us to the commit before head, which is first pass of Fibonacci program. So if we type something like git checkout head tilde 1, this extremely scary message will go off on the screen, but ignore it. It doesn't really matter all that much. What's important is, what we've just done is we've travelled back in time. Head, which is, remember, where we currently are, is now first pass at Fibonacci program, right? We've travelled back in time. Our project is now at that state it was in a little while ago. And look, we can look at the files in our directory. We can see that we don't have the README anymore. And if we print out the Python script, we don't have the long explanation of the first 10 Fibonacci numbers are. So yeah, the changes that we made since have been temporarily removed, and we just have the thing that we had after the first commit. So that's how you travel in time. Now, let's go back to where we were. Now, ignore the fact that I've written main there, but you could have, for example, written git checkout and then the hash, but git checkout main works as well, and I'll explain why in a minute. And then we've got our files back. So we can travel backwards and forwards in time, no problem, right? If we want to see what our repository looked like a while ago, easy enough to do. Okay. Right, now, I am going to talk about branches. So, we don't just want a series of commits going forward in time. That's not particularly realistic, right? Software development doesn't necessarily happen in a linear fashion. Sometimes we want to try out new features or make some fundamental changes to how our program works while still having a working copy, right? And that's important. We need to do that. So we have branches to accommodate this need. So you can think of a branch as like a series of commits. It's like a timeline. That's just sort of another valid way of looking at it. The default branch when you run git init to start a project is called main. Historically, it's also called master. You'll see those kind of used interchangeably, but there's sort of a push now towards using main as the default. So you'll see either, just don't be surprised by either of them. So the branch called main is generally used as the up-to-date or stable version of your project. Okay, so that's where you want it always working. Anything you commit to master or main, you always want it to be a working and fine copy. Right? And you can use branches to do experimentation, to develop features, to fix bugs. And we'll look at an example of doing that now. Oh, sorry, another slide before we do that. Sometimes we want to experiment, and it helps isolate feature development. So say we've got a working copy of our program, we want to develop a really complicated new feature. We can either have it partially working in our main copy of it, or we can separate it off to one side, and we can still have our working copy on main. It's also good for collaborative work, but we'll get to that later. So in terms of how we do this, it's yet another subcommand. There are so many of these subcommands. Again, feel free not to learn them for now, just to know that these concepts exist, but I'll be using them for the demo. So you can use the branch subcommand, and you'll create a branch that starts where you currently are. And if you want to commit to the new branch, you have to switch to it. So it's always the case that when you're working on a Git repository, you are on a branch. It's almost always the case that you're on a branch. And so you need to switch to the branch that you want to save to. So let's look at an example. So say we're working at Fibonacci Industries, and our boss tells us to let the user input some things and have us react to it. So we're going to create a branch for this new feature called user input. And if you look at the purple indicator on there, when we create the branch, we're still on the main branch. So creating a branch with git branch doesn't switch to it automatically. You use git switch, user input, and it switches our branch. And now we're on user input. And so if you run this command git branch without an argument, it just lists the current branches that you have in your project, and it tells you with a little asterisk which one you're currently on. Okay. So let's develop this feature. So let's let a user input a number and print the first that many Fibonacci numbers. Okay. So we've got a couple of things that have changed here. So we import sys. Again, don't worry if you don't know Python. This really isn't important. We're just taking user input, we're assigning it to a variable, and we're changing the number of things that we print out depending on what the user gave us. I'll just show you an example. The code isn't important, but we've changed some lines, and that's the important thing here. So if we run Fibonacci.py6, then it prints out 6 numbers of the Fibonacci sequence. If we run Fibonacci 50, it prints out the first 50 numbers. Okay, so we're just varying the output based on that input to the script. And so let's save it in the way that we've been saving it before. We use git add all, just to save the progress to Fibonacci.py. And we commit it with the message, user can now set length of sequence. Okay, so we've done another save point. But we've done a save point this time, we've done a commit on this branch user input. So the branch main won't have this commit. It just exists on user input. But this feature isn't complete yet, because if a user types Fibonacci.py cheese, it's going to throw an error, right? Because cheese isn't a number, it's delicious, but it's not a number. So we want to catch that error and handle it. So we're going to make a change to our thing, we're going to use a try except, whole thing, we'll just make a change to our code to catch it and deal with it. And look, we fixed the bug. And then we do the same thing, we just save this as well, git add all, git commit with added exception handling for user input. So anyway, the point is we've done 2 commits on this branch. So we've done 2 different things. We've added the feature, then we've fixed a bug, whatever. So that's what Git branch is used for in the abstract. And now if we look at our log, So I just typed git log, decorate, color, or whatever. And you can see that main is still back there. But user input, we've actually been adding more things to that branch. So user input has these last two things that we've done, but main doesn't. Okay? So if we were to switch to the main branch, we would still be where we were 2 commits ago. We wouldn't have any of this user input stuff. Okay? That's what I mean by alternative timelines, right? The user input timeline is further ahead, and the main branch doesn't have those changes. So, that's branches. Hands up if you're still with me. Good. Awesome. Great. Just see where I am in terms of time. That's roughly where I wanted to be, actually, so that's good. Right. So, branches are great, but the problem is we can't diverge forever, right? We can't keep creating these branches and not doing anything with them. Sometimes we're going to want the changes from multiple branches on the same branch, right? So the whole point is, say you're, I'll give you sort of a motivating example for this. Say you're developing a feature, and you eventually want it to be in your stable version. You need to do that by merging 2 branches together, merging the changes from 2 branches together. It could be anything though, it could be bug fixes, it could be features. So, we use the following terminology to describe what we're doing here. We merge branch B, say, into branch A, and that gives branch A the changes from branch B. Now, I know that's a lot to take in. I'm going to do an example. It's fine. If you didn't understand that sentence as I read it, it's okay, you will in 5 minutes. So, here's how you actually do this, right? So, you've got to switch over to the branch that you want to merge something into. It's a bit unintuitive, right? You don't merge to the thing that you want to merge into something else, you merge into the thing that you want to take in the changes to. And we use the merge subcommand to merge, and this creates a new commit. And the branch that's been merged in does not change. I will explain this with pictures because this is the best way to explain it. So, you can imagine these circles as our commits, and you can imagine sort of, so on the blue branch, we had the changes black, black, blue, blue, and on the orange branch we've had the commits black, black, orange, orange, orange. Maybe that looks more red on this slide, I think, but I think it is orange on the screen. So what we want to do now is we want the blue branch, say the blue branch is our main branch, right? It's the stable version of our program. We want that to have the changes from the orange branch, because this is a feature that we've been developing, and we want this feature to go onto our blue branch. It's ready now, we've tested it, it's all good. So what we do is we switch to the blue branch, and then we type git merge orange branch, and this happens. So essentially the changes are moved over to here, and we have a new commit that sort of says, oh, we merged this into here, by the way. Okay? Now, I'll show you what this looks like with our Fibonacci project, right? So, say for the sake of argument that while we were developing this really complicated user input feature, our bosses came to us and said, oh, the users feel like we aren't saying goodbye to them or something, and we had to write this little goodbye message at the end of the program output. Thank you for using the Fibonacci printer, remember to have a great day, or whatever. But they wanted those changes immediately, right? So we did those changes on the main branch. Okay, and if we run git log, that's what it looks like. Oh, that doesn't show up very well on the screen. Can you see those red lines? Just about, if you focus, right, good. So you can see it kind of diverges like this, like a V shape. And we've got the user input on the head of one of those branches, and we've got main, the change that we just made to say goodbye to the user, on the other branch. Okay, well now let's say we've finished developing this user input feature and we want to merge it into main. So, what do? Well, we switch to main and we merge user input. It really is as easy as that. And most of the time, this just works. And it just works in our case. What it'll do is it'll open the editor again, and you get to type a commit message. I normally prefer a bit of an explanatory one, so we say, okay, merged in new user input feature or whatever, and that'll be what the commit's called. And then it's done. It'll show this very happy list of pluses and minuses. What this actually means is that since the last commit on main, we've added some lines and we've removed a couple of lines. Oh yeah, I should probably say as well, so the way that Git thinks about commits is by thinking about diffs. So the lines that have changed, right? What lines have you added to the file? What lines have you removed? So it's kind of a line-by-line thing. And that'll be important in a second. So anyway, this has given us this log. Oh, this has given us this file. So you can see, right, we've got the thing where we say goodbye to the user from main, and we've also got the user input stuff and the error handling from user input. So it's actually merged the changes together into a single file, which is really cool, right? And this works automatically the vast majority of the time, especially if the bits of the file that have been changed on the different branches are different. So look, I mean, in the user input stuff, we've dealt with the beginning bit of the file, and with the greeting the user thing, we've dealt with that at the end of the file. And because, you know, they're in different places, Git finds it really easy to merge that. And Git can do it automatically. Neat, right? Unfortunately, sometimes on both branches, that isn't the case, but I think I've got another slide before that, actually. I do. So this is what the log looks like. So you can see that it's kind of a bit like a trapezium, you know, right? We go out for user input, and you can see there's a line from that final commit of user input going to main, which means that main now has the changes from main and also the changes from user input. And in general, we can tell what changes a particular commit of our program has by looking at the log and just sort of following all the lines going out of it downwards. Right? So if you look at main, right, it has all of the changes. If you look at user input, it doesn't have this change on main, but it's got all the other changes. Okay, so that was my demo of merging. Hands up if you're still with it. Good. Little tricky, you are going to want to practice this one. And in particular, you're going to want to practice this, because sometimes things go wrong with merging. And this is kind of one of the degrees of difficulty that Git has. If you're changing the same part of the file in the two branches, Git doesn't know what to do. It's smart, but it's not that smart, and it doesn't know, for example, how to merge two Java expressions into a Java expression that combines both, or something like that, right? It's not smart enough to understand code. But it does understand that sort of different lines are being changed in different ways. So if you change the same line of code on both branches when you merge one into the other, this is called a merge conflict. And you have to resolve it manually. You have to pick which branches changes to the same lines you want to keep and which you want to throw away. Now, I'm not going to do a demo of a merge conflict because it would take up a significant portion of the talk. But it's not too hard to resolve. You just need to stay calm and look it up. Basically, you just need to look up the stages for resolving a merge conflict. Essentially, Git will edit your files manually and show you which bits are from which branch. I recommend using what is called a merge tool, and you can just Google the phrase merge tool, and it will show you a list of bits of software that will help you with resolving merge conflicts, and they are really, really useful. So just use the merge tool for this. But this is one of those things that I think is slightly beyond the scope of this talk, and I'm just going to leave it for now. So sorry about that, but it only comes up occasionally, but it's probably the thing that panics new people to Git the most. Which is why I thought I'd mention it at all. So that is merging done completely now. One thing I will go over, though, is that sometimes we make mistakes or we want to change the path in life and in code. But in code, there's an easy way of doing it, so let's talk about that. Part of the benefit of version control and keeping track of the history of your project is that we can fix mistakes that we make really, really easily. So there are two subcommands that are really good at this. One of them is the revert subcommand, and one of them is the reset subcommand. Now, this one is a little more dangerous and a little more tricksy, and I'm not going to cover it in this talk, but I will show you revert quickly, because we've got so much to do in this talk, and I think revert is useful enough to make the cut. So, say that I accidentally, the fool that I am, add of my own volition print frog to the end of this program, right? You know, we don't want the word frog to just appear in the output of our program, and I realise I've made a mistake, but unfortunately I have already committed it at this point. Committed the change where I just print the word frog. Damn. Right, well, I want to get rid of it, and the way I get rid of it is I type git revert. Now, remember, there are lots of ways to refer to the commit. So this commit has a name, which is a hash. You can also call it head, because that is where we currently are in the project. You can also refer to a commit. If it's the last commit in a branch, you can refer to it by the branch name as well. So this commit has lots of names. You can call this commit head main or 044223A. So if you type git revert head or git revert 044223A, do the same thing. You can even type git revert main. That would also do the same thing. What it actually does is it adds a commit whose only purpose is to undo the last commit. So you know how I said that Git sort of thinks of commits as a series of, basically a list of what's changed, right? A list of what lines have been added and what lines have been removed. Well, it'll just do that in reverse. So you can just, the title that it'll auto-generate for is revert, and then the title of your old commit. And we can just do that, and it will add revert added frog to as a new commit. It'll just undo that change. But it doesn't remove the fact that we made the mistake in the first place. It just adds another commit which explains that we've undone it. So, it's quite useful. Git reset, which was the other one that I mentioned, can actually undo and erase a commit. But that's why it's a little bit more dangerous. It's why I don't want to sort of talk about it right now. Now, that is all the stuff that I want to talk to you about that deals with local work. So if you use the stuff that I've talked about so far, so commits, branches, merging, logs, checkout, switch, and revert and reset, and all these other things, you can use Git for your courseworks, and it will be useful, and you'll get some value out of it. And I highly recommend you do that. As I say, right, the best way to learn Git is by doing, and while I can tell you how Git works in a very general sense, you can't learn how to use these terminal commands just by watching someone do them. You have to experiment yourself. And so I highly recommend that people just set like a reminder for, say, a month's time when you're actually doing coursework to use Git to track the changes to it. It's very useful. But now we're going to talk about another thing, and this is sort of a section of the talk I've expanded since I first did this talk, because this is also very useful, right? You want to do work in a remote sense sometimes. So you want to have copies of your project exist online for several reasons. I mean, it's kind of a backup of your project if you think about it, right? If you delete the local file and you have a remote copy, you can just get the remote copy again. And there are lots of services that let you host your projects and deal with remote copies of them. The most famous one by far is GitHub, and I imagine that everyone here, even if you've not got much experience with Git, has heard of GitHub before. It's a huge company. It's now owned by Microsoft, I think. And they offer remote repo hosting. By far, they're the most popular. So I'm going to show you a few screenshots from GitHub and sort of explain what the deal is and how you can get sort of value out of that as well. So this is a GitHub repository for the demo that I've been doing for this talk. Right? So, now the reason I created a readme.md, I'll just note this, is that if you go to the GitHub page for a repository, it'll show you the contents of the readme.md. So that's essentially the about me of the project. It lists the files that are in the project. If you click this button, you can see all the commits that we've done. You can see that the most recent one is revert added frog, right? That's the one we did most recently. And there are lots of buttons to click. I'm not going to click all the buttons, but this is what a GitHub page looks like. This is a very visual and intuitive sort of description of your project, right? So GitHub can be useful for that as well. It's quite easy to navigate. One other thing that you can do on GitHub, and I don't recommend this for code, but for text files, you can actually... okay. I forgot which slide was next. So we talk about remotes. So the way that we can connect our project to GitHub is we go through the GitHub interface and we press create a project, we give it a name, and then on our local copy we type something like this, right? So I'm not going to go into exactly what all this means. I think this is best learned by doing really, and GitHub gives you very, very detailed instructions. But if you type git remote add, that adds a new remote repository to your project. You've got to give it a name. The standard name is origin for whatever reason. But it is, everyone just uses origin. And then you use a special URL. I'm not going to go into it, but that's the name of the repository on GitHub. And then we use this thing called push to send all of our changes there. I'm going to talk about push a bit more in a second, but essentially push means take the stuff I have locally and put it on a remote repository. A bit more bit more detailed than that, I'll go into it in a second. So yeah, remotes and cloning. So I'm not going to demo this, but you can get a local copy of a repository that exists on GitHub by typing git clone, and that will download a local copy that looks the same as the copy online. Depending on permissions, whether you have permission to contribute, you can also contribute to the repo. And actually some popular software like command line utilities and this sort of thing are distributed using remote Git repos. So they'll just say, here's the URL for this piece of software you want, just type git clone URL and you'll get the software downloaded. So if you have a branch locally, it can correspond to a branch in a remote repository. So we call them like remote followed by branch. So origin main is like the copy of the branch that exists on GitHub that mirrors your local copy of main. Now the content won't necessarily be the same, right? You might have made changes on GitHub and not downloaded them, or you might have made changes locally and not uploaded them, but they refer, at least in principle, to the same thing. And you can also create branches locally that you don't put on GitHub, and vice versa. Now, there are these three verbs that you need to know about remote repositories. Fetch, push, and pull. Push and pull are the most important of the two. So, if you fetch something, you get the remote repository to tell you what is different on the remote repository to your local copy. Pushing will update the remote copy with updates that you've made locally. So if you've made changes locally, you push them and they go online. And if you've made changes to the online copy and you want them locally, you pull them. It's kind of a natural metaphor, right? You push it out, you pull it in. So let's make some changes. You can actually make changes using the GitHub UI. And I don't necessarily recommend this for code. I definitely don't recommend this for code. But for example, if you're just changing the README file or some other text file, it's fine. The reason I don't recommend it for code is that you can't test it. Right? So you just got this online text field. So let's add this last line. I've made an edit using the GitHub web interface. And then if you scroll to the bottom of the page, you can commit it. Yes, this is my Warwick email address. So I originally had my personal email address on there, and then I realized I shouldn't do that. But yeah, you just commit it using a commit title, right, like you would normally on the command line. Change README using the GitHub web interface, and you can commit directly to the main branch. And look, it appears on GitHub now, and it appears as our last commit as well. So we've made a change, we've made a commit that appears online. How do we get it locally? Well, we pull it, right? So we type something like git pull origin main, and it will say that it's downloaded a new commit. And if we look at tail, I don't know if you've come across tail, I realise now, but tail just prints out, or tail-n1 just prints out the last line of a file, okay? I've made an edit using the GitHub web interface. So we have this change. And it will appear in our log as well, although I'm not sure if I have a copy of that on the slide. So let's do the opposite. Let's make a local change and let's push it online. So I made another edit locally. I will now make this appear on GitHub. And like normal, we add the change, we commit the change, we describe the change, and then we say git push, origin, which is the name of the remote we want to push to, main, the name of the branch that we want to push. And it will say a load of stuff. And the change appears on GitHub, right? We've made a local change, and it says it here. And so this, very simplistically, is how you work with remote repositories. You pull the changes in if they're online and not on your own machine, and you push the changes if they're on your own machine but not online. And this way you can kind of keep a backup copy of your work. Shouldn't be thought of as a backup, you should always make other backups, but this is extremely helpful as well if you're collaborating on something. As you can imagine, right, you can each push and pull these changes. You can have branches based on your own work that other people don't have access to, and you can merge them into main when they're all ready and things like this. So this is a way of managing work with other people as much as anything else. It's very useful for that. And talking about that, pull requests. So I felt like I shouldn't demo them in this talk, but I feel like I should explain what a pull request is. It's a silly name for what it is. But basically, so say you've got a repository that lots of people contribute to. When you've made changes on your own branch and want them incorporated into the main branch, normally the main branch, you essentially formally ask the person who owns the project to do that. And that's what a pull request is. And I'm not going to go into much detail on this because GitHub's pages on this are a really good explanation of what a pull request is. And I think it would just confuse the matter if I talked about it here. But this is kind of, again, it's a bit like the merge conflict stuff I talked about earlier. You'll need to know this, but this is easy enough and natural enough to discover on your own when you get to that stage. And it's a silly name, because it's got nothing to do with pulling. It should really be called a merge request, because that's what you're requesting happens, right? You're requesting that branches merge together. So, but yeah. So, I'm just going to finish the talk now with some top tips, okay, and some other things talking about best practice, and really what I want people to take away from this, apart from the general techniques and stuff that I've talked about. So, there's a piece of advice on here that appears twice. Do not commit secrets. If you have things like an API key or a password, don't add them to Git. Just don't add them to files that you commit to Git. It's a bad idea, because Git will remember. Even if you revert the commit, remember, the changes are still there. Even if you reset the commit and in theory erase it, the changes are still there. If you do accidentally commit a secret, some sort of API key or password or something, change it, because that's the best way of getting around it. In terms of the best way to manage a Git project, well, you should do what I've been doing during this talk, which means you should commit little and often. Ideally, you only commit when you've got a version that compiles or runs. It's not good to commit a broken version in general. We like to commit a version that at least works. It's important. Because then when we travel to the past to look at it, we'll actually be able to run it and make it work. So it's handy. And if you do need to revert them, it's much less painful to revert a tiny change than a huge change. In terms of how you should manage branches, well, okay, as I say, you should keep main to be the up-to-date and stable version. Make small branches for small features and merge them in. It's the best way of doing it. You can clean up dead branches. So if there's a branch that you've merged in and you don't want to use anymore, delete it. Just get rid of it. It won't remove the commit, it will just remove the name of the branch. If you've merged the changes in, it should be fine. And in fact, it won't let you do it. It'll really discourage you if you haven't merged the changes in. So this is kind of safe to use. Now, some of you have just learned about the command line yesterday, so I don't expect your enthusiasm for it to be particularly high. If you don't like the command line, that's fine. I mean, you should ideally get used to it, but you don't have to use the command line for Git if you don't want to. There are lots of ways of using Git in a way that don't require you to memorize a bunch of commands. There's a thing called Git GUI for Windows and Source Tree for Mac, and from what I hear, they're both very good, although I've never used them. Virtually every modern IDE in existence has a Git plugin. Quick show of hands who uses VS Code, because that's the current hotness, right? Yeah, right, several of you. VS Code has a Git plugin. It's very good. If you use an IDE, there's no excuse to not have a Git plugin, really. Even the fancier text editors have Git plugins and Git tools that you can use. Even ones like Vim and Emacs do, right? So pretty much everything that you could write code on has a way of tracking code. It's just inbuilt into everything now. So how to install Git? Honestly, this slide is mainly there because the slides will be available later. But yeah, you just go to the Git page and download it. If you use Linux, it's already installed. Like 99% certain it'll already be installed. It's just ubiquitous now. It'll be on your Linux install. Couple more little things. So sometimes there are files in Git that you don't want to keep track of. So for Java, like .jar files, sort of compiled versions of files, right? When you compile it, you create a file normally, but you don't want Git to track that file because, well, it's redundant, isn't it? Like, you know, you've already got the source code. You can create the compiled file at any time. You don't want Git to keep track of it, and they're binary files. They're going to be big. And they're hard for Git to look for the differences in, because remember, Git looks at the differences line by line, and a binary file doesn't really have meaningful lines, so it will be quite clumsy with it, really. So you don't want to track that sort of thing. The same is true with like installed libraries, so like a PyCache or a node modules or something like that, or a database file. You can create a file in your repository, not in the .git folder, outside the .git folder. You can create a file called .gitignore. And if you put a bunch of regular expressions in there, so for example like star.jar or star.db or anything like that, it will ignore those files. So it won't tell you, when you type git status, it won't tell you, oh, you haven't added this file yet, by the way. It will just completely ignore it. And that's really, really useful. So that's the thing that I think you should be aware of. There are details, but I'll let you figure the details out by yourself. I think knowing about this feature is the important thing. Similarly, Git has a config. It's got a huge amount of things that can be configured, actually. It's incredible. You can configure the default editor that you use when you type the commit messages in. You can configure the commit template. You can have a global git ignore. So if you never want to track database files, you can set it to never track database files. We talked about merge tools. You can set your default one there. All these sorts of things. Default login credentials to GitHub. All this sort of stuff. Right? And there's a config subcommand to conveniently edit them. And you can do it on a user level and a system level. So it's all very configurable. Now, stuff's going to go wrong when you use Git. Everyone makes mistakes in general, and Git's quite a blunt instrument sometimes. It can be difficult to use. I've already told you about merge conflicts, right? That you can resolve those wrong sometimes. It's really, really easy to do. Everyone makes mistakes, don't worry. It's pretty much all undoable. One of the great things about Git is there's pretty much always a way to recover from whatever you've done. And this is a brilliant website which I have used several times, ohshitgit.com. It contains a lovely list of scenarios of ways that you have sort of managed to set your project on fire or mangle it in a particular way. And there are sort of workflows that you can use to fix that. Just stay calm and look it up, and someone will have done what you have done. It's impossible to mess this up uniquely, I promise you. So this is a good resource for that, and I kind of want to point people towards that as well. This talk, if I wanted to tell you about all the features that Git had, this talk could be 4 or 5 hours long, just telling you about them, much less explaining them. You can get real value out of using Git in the way that I've described in this talk, just doing commits and branches and merging and remotes. You can get real value out of Git by doing that. But if you want to sort of expand your Git foo and sort of learn more, here is a list of other things that Git can do. I'm not even going to explain, but I'm just going to leave this list up here in roughly the order I think you should start looking at them when you're comfortable with the sort of basic concepts. Right? So stashes are cool, and I think they're the next thing that people should look at, but there's all this other stuff as well. And Git has extensive and quite clear documentation, although it can be written in a bit of an obscure way sometimes, and explaining all of this. And also, at this point, because Git has such a dominant market share, there are about 9 tutorials for every single one of these concepts. So yeah, I'm leaving this one here mainly because there's, as I say, the slides will be available, and when you get comfortable with the stuff I've talked about, this is the next thing you should look at. It's basically it. So how to learn more? Again, this is just another lovely list of resources for you. The Git reference, which is essentially the official documentation, is there. There's a book, it's an online book, but most books are on here. You can learn Git branching using this kind of game, kind of practice exercise thing. That's quite cool. And GitHub, the website, have many useful help pages on a lot of the topics I've talked about, especially the stuff that pertains to what GitHub does, which is offer remote repository services, right? So all the stuff about pull requests, GitHub is very, very helpful telling you about all that. That's it. Thanks for putting up with me for an hour. And even if a lot of this has been a bit overwhelming, I know you've had to consume a lot of information this week, just take away from this talk what Git is, why people care, and that you should ideally practice using it during your degree. Okay, thank you, that's it. Does anyone have any questions before? I'm eyeing up the pizza at the back of the room, but before that, does anyone have any questions about the stuff I've talked about? Yes?
When you use the branches in command line,
yeah.
Is it necessary to put the line and the cat?
Oh, right. So the reason I did that is because if I didn't do that, it would send me to a new window, and I just wanted to keep it in that terminal session. You don't need to do that at all. That was just me keeping it on this slide, basically. Yeah. Yeah.
Are you exhausted between GitHub or GitLab that become
So, in terms of features, they're basically at feature parity. GitHub is a lot more popular, so if you ever have any problems with it, then you probably find an answer a bit more easily on GitHub. But GitLab is basically the same thing. It's sort of, differences between social media sites kind of difference, right? It's superficial mainly, but yeah, not really. Yep.
How do we get access to the slides?
You want me to go back a couple of slides?
No. How you said you're going to send us slides.
Oh yeah, so if you're in the Compsoc Discord, I'm sure they'll definitely be posted there.
In the
The Compsoc, the Computing Society Discord, I think they'll probably be sent out in the Compsoc newsletter as well. But I haven't actually given them to Josh yet. I have to do that. But yeah, I'll make sure they get out, and I'll make sure that everyone's got a copy.
They'll be on our website as well.
Yeah. Okay. Yeah. Exactly. Yeah. They'll be on the Compsoc website. Cool. All right. Thank you very much. There is, I believe, food in the back of the room if people want to. Go for it. It's been a pleasure. Hope you enjoy the rest of Welcome Week. Hope it all goes well.